This is r.d.sharma solution class 12th. We are taking exercise 19.18 from chapter number 19, indefinite integrals. In this question, we have x to the power 2 by 3. So how are we going to go about it? The basic thing is we need to get something from the denominator to get the numerator, since we don't have any numerator here. So we ought to get x power 2 by 3. For that, we know differentiation is nx to the power n minus 1, that you already know. That means if we take t equals to x to the power 1 by 3. Now you will ask why we need x raised 1 by 3. As I mentioned, differentiation is x to the power 2 by 3. And since this x square is there, means x 1 by 3 square, and 4 is also 2 square. So this x 2 by 3 minus 4, this can be written as x 1 by 3 and to the power square, that is to the power 2, minus 2 square. This is what we wanted, x square minus a square. So the formula, if we take this x raised 1 by 3, then it will be squared. That's why we have taken t equals to x to the power 1 by 3. When we differentiate this dt by dx, it will be 1 by 3 x to the power 1 by 3 minus 1, and this will be negative 2 by 3. 1 minus 3 by 3 will be negative 2 by 3. So this will go negative 2 by 3, and this negative means it will come in the denominator, so it will go along with dt. Since we have this 3 dt, dx is in the numerator and x negative 2 by 3 will be in the denominator. So this whole dx divided by x to the power 2 by 3 is what we got when we take t equals to x raised 1 by 3. So 3 dt we got. So the integration will be something like this. So we have this dx by x to the power 2 by 3. So dt, this is 1 by 3, and this will be under root x to the power 2 by 3, because we have taken x raised 1 by 3 as t. This will be t square minus 2 square. Now we have formulated in terms of a formula that is easily integrable. We have a direct result for dx by under root x square minus a square, and that will be in the log term. You know already that. So this will be 1 by 3. It's not 3. I'll just change it. If I'm not changing it, it will be 1 by 3 only. Log t plus under root t square minus 2 square plus constant of integration. We will replace now this t by x to the power 1 by 3. So 3 log t is x to the power 1 by 3 plus under root t square, that is x to the power 1 by 3 whole square. 2 square will be 4. So x to the power, originally what was there will come eventually. X raised 2 by 3 minus 4 plus constant of integration. That's your final answer. Now this is how we are going to go about it. And this is a simple reference, but the basic concept is, if you are able to foresee x to the power 1 by 3, that will be enough. Now if you are aware of the differentiation in a good manner, then you know sine inverse x differentiation will give you 1 by under root 1 minus x square. So if t equals to sine inverse x, dt by dx will be equal to 1 by under root 1 minus x square, and that is what we have in the denominator as well. Dx I am taking here now. So this dx and this under root 1 minus x square. This under root, there are two terms in the under root. So let me resolve it. And you already know under root a into b will be equal to under root a into under root b. So you can just separate them out, 1 minus x square here, and this will be 9 plus sine inverse x whole square. Now we have dx in the numerator now, so integration will be something like this, dx by under root 1 minus x square. Sine inverse x we have taken as t, 9 can be written as 3 square. So integration will be something like this, dx by under root 1 minus x square we just got as dt, 9 I just requested you that it is under root, okay. I have not written under root right now, but it will be inside under root. 9 was 3 square. Sine inverse x as t square. Everything is in under root. So let me just place it inside the root. Now we have a direct formula for a square plus x square or x square plus a square that we will use just now. Log modulus t plus under root. So we'll keep it here. See, 9 plus sine inverse x whole square will eventually come, but we'll go step by step. 3 square plus t square log t is what? It's sine inverse x. So it's sine inverse x plus under root 9 plus sine inverse x whole square plus constant of integration. This will be your final result. So this is how you are going to go about it. The concept main is sine inverse x will give you 1 by under root 1 minus x square. The second thing is that you have to separate these root terms. Third is formula, that is under root a square plus x square. So for integration, the first precursor is the differentiation. Differentiation, if you are aware, everything will be easier for you. Now cos x by under root sine square x minus 2 sine x minus 3. So you know that sine x will give you cos x, so you are going to get the numerator easily, and denominator will form a quadratic equation. And that quadratic equation can easily be converted into the formula of easily integrable form. So I'm taking t equals to sine x. dt by dx will be, sine x will be cos x. So dt will be cos x dx. That is, of course, in the numerator. This whole is in the numerator. So you have dt here. So this integration will become like this. dt by under root sine square x minus 2 sine x minus 3. Sine x we have taken as t. So the term inside, or the equation inside the under root, will form like this. So this will be t square for sine square x minus 2t minus 3. So this t square minus 2t minus 3. Now we want to make it as a perfect square. For that we'll take the coefficient of t, which is 2. We'll divide it by 2, that will give you 1. We'll square it, that will be added and subtracted. So a square plus b square minus 2ab. T minus 2 whole square minus 3 minus 1. It will be minus 4. So minus 4, it will be 2 square, minus 2 square. It will be perfect square. And we have the formula for the perfect square. So this will be dt by under root t minus 2 whole square minus 2 square. That is x square minus a square. So this will be dx by under root x square minus a square formula we are going to use. And since r.d.sharma has clearly given these formulas and the results also, and they have tried to prove it also. So here we will take x as t minus 2 and a as 2. So this will be, let me write the direct result, log, it's not t minus 2, it's t minus 1 actually. See, t square minus 2t plus 1 is a t minus 1. So there is a mistake which I committed. Now I'm trying to just mitigate that error. So just imagine that t minus 1 whole square is the actual one previously. Alright, now coming to the solving x equals to t minus 1, you are going to take a will be 2. So log t minus 1 plus under root, this whole is going to come. T minus 1 whole square minus 2 square. You already know from where it has originated. We have already done that. Now replacing this t by sine x finally. So log modulus sine x minus 1 plus, now don't worry about this. Even if you open it, it will be same stuff from where we started. There is a pattern, if you have noticed, that whatever is inside the under root will come eventually directly like this. It will be sine square x minus 2 sine x minus 3 plus constant of integration, of course. That's your final answer. So this is how you're going to go about it. I hope you have a better idea now, because this is sine x will give you directly cos x, so we don't have any trick here. Under root cosec x minus 1. Now this is a tricky question. Why tricky? Because there is nothing to keep it at as t so that we can get something inside. So whatever we have in our hand, let's make it easier or make it simpler. Cosec x can be written as 1 by sine x. Let's take the LCM. It will be 1 minus sine x divided by sine x. This 1 minus sine x by sine x, and this is of course in under root. I'm just trying to tell you what are we going to get, because we have to find a way so that we can integrate it. Right now cosec x minus 1 under root is not integrable easily. So we have to make it in certain way. So we need to rationalize it. In order to rationalize it, why we are doing this? Why are we rationalizing it? I'll just tell you right now in a bit. But under root 1 minus sine x and 1 plus sine x will give you 1 minus sine square x. 1 minus sine square is cos square x. Under root cos square x will be cos x only. I hope you got the point which I am making. I'm just trying to say sine square plus cos square equals to 1. 1 minus sine square x, because 1 minus sine x into 1 plus sine x will be a square minus b square, 1 square minus sine square x. A square minus b square will give you what? It will give you the 1 minus sine square x, and that will be cos square x. So I'm writing it now, 1 minus sine x into 1 plus sine x. Denominator will be sine x into 1 plus sine x. So under root, this will be sine x into 1 plus sine x. You can just multiply this, sine x into sine square x. So let me multiply and write it, sine x plus sine square x. Now as I was telling you, this 1 minus sine square x will be there, because a minus b into a plus b will give you a square minus b square. A is 1 here, b is sine x here. So 1 square minus sine square x, that will give you 1 minus sine square x, and that is going to be cos square x. And since it is under root, it will give you cos x only. So cos x will come. What is in the denominator? Let's start with the higher power. It will be sine square x plus sine x. So sine x can give you cos x easily. Now we are onto the track of solving it. So t equals to sine x. Until now we have just simplified it. Now we are taking t equals to sine x. Dt by dx will be cos x. Dt will be cos x dx. So when we integrate it, it will be cos x dx. This cos x dx will be dt. So integration will be like this. It will be dt in the numerator, under root sine square x plus sine x. So sine x, if we have taken it as t, it will be t square plus t. But now we have to make it as a perfect square. T square plus t has to be converted into a perfect square so that we can apply some formula. What do? We will take the coefficient of t, which is 1. We will divide it by 2, which will be 1 by 2. We will square it, which is 1 by 2 whole square. We will add and subtract 1 by 2 whole square. That's what we are doing. So a square plus b square plus 2ab, that is t square plus t plus 1 plus 1 by 2 whole square, is t plus 1 by 2 whole square. These three have been taken out. 1 by 2 whole square will remain like this. So this can be written as integration of dt by under root t plus half whole square minus half whole square. And you know that x square minus a square under root formula, we have been using it for a while now. Log t plus half under root. Under root, same thing is going to come. Sine square x plus sine x will eventually come. Even if you open this or write it as t plus half whole square minus half whole square, even if you do that, this whole, when we replace t finally or revert back to sine x equals to t, which is t as sine x, so sine x plus half plus under root, what is inside this? T plus half whole square minus half whole square. Same thing will come, because eventually this has come from the sine square x plus sine x only. So just write sine square x plus sine x in this case, and that will come with practice. If you do 2 or 3 times this question or this type of question, this will be easier for you, plus constant of integration. That's your final result. Okay, what we have discussed, it is in front of you. You can solve it and write it like this, but the concept and the things which we have done is being explained to you by me just now. Constant of integration is very important. That is the difference between the indefinite integral and definite integral. So if you don't write c, that will not be very good. Next is sin x minus cos x by under root sine 2x. Again, same thing we are going to apply or adopt. We need sin x minus cos x anyhow. So how can we convert this sin 2x in order to get sin x minus cos x? Because if we have this sin x plus cos x with us, when we take it as t and we differentiate it, dt by dx will give you sin x will be cos x and cos x will be negative sin x. Now you see we have got the numerator, just a negative sign. If you take it out, you will get the numerator. So in order to get the numerator, we ought to convert this sin 2x in terms of sin x plus cos x. That is the tip which I can give you for this question. As one of the questions which we are going to do will require this again. So you need to understand it very carefully. Sin 2x, if it is there, when we add 1 and subtract 1, this is why we are doing. Because for 1 we can write sin square x plus cos square x. Sin square x plus cos square x is 1. So we can write this sin square x plus cos square x. Sin 2x will be 2 sin x cos x. This negative 1 will remain like that. Now this a square plus b square plus 2ab, it is a plus b whole square. That is sin x plus cos x whole square. We can write it always. And there is a minus 1. Now the question is, or the solution is taking shape, because initially I told you we need sin x plus cos x anyhow. so that we can get the sin x minus cos x into dx in the numerator. So let me write it formally. Integration will be like this. Numerator is sin x minus cos x. Denominator is under root sin 2x. I will write it as sin x plus cos x whole square minus 1. I am writing it in short. Sin x plus cos x, already I have taken it as t. Dt by dx is cos x minus sin x. But the numerator is sin x minus cos x. So for that we will take a negative outside. So negative sin x minus cos x. So dt, negative take on the left hand side. Dt will be equal to sin x minus cos x dx. So that is what is in the numerator. So the numerator can be written as negative dt, minus you can take it out, it is dt, divided by under root sin x plus cos x whole square is what? It's t square minus 1 square. And now under root x square minus a square has a simple solution for that. So we have log, negative log, modulus of t plus under root t square minus 1 plus constant of integration. Now this t was sin x plus cos x. So let me write the final answer. I am replacing t by sin x plus cos x just now. So it's sin x plus cos x plus under root. Now as I told you earlier, whatever you do, the question which is having under root in the denominator, and for that, using that we get the numerator, everything comes same. Because originally sin 2x was there, we added 1, we subtracted 1, we converted it into a form so that we can integrate it easily. But here t square minus 1 is simply sin 2x only. So this will be sin 2x only plus constant of integration. So this is the solution. Some intermediate steps I have skipped, but whole solution or reference is in front of you. You have to follow this in order to get the answer. So it's a different kind of question. Now you understand well. Now this question, cos x minus sin x divided by 8 minus sin 2x. We have just done a question in the same way. We need cos x minus sin x, and you already know how to get this. But we have to convert this 8 minus sin 2x in such a way so that we can get the cos x minus sin x. So this 8 minus sin 2x. We can write this 8 as 9 minus 1. 9 minus 1 is 8 only. It could have been done as 7 plus 1 also. But 9 minus 1 is better because 9 is 3 square. So 9 minus 1 minus sin 2x. So we got 9 minus 1. But this minus 1, we know sin square x plus cos square equals to 1. In place of 1, I am writing sin square x plus cos square x. Sin 2x, I am writing 2 sin x cos x because sin 2 theta is 2 sin theta cos theta. Now 9, if I take a negative outside, everything inside will be positive. That is sin square x plus cos square x plus 2 sin x cos x. And this is simply sin x plus cos x whole square. A square plus b square plus 2ab is a plus b whole square. So sin x plus cos x whole square it will be. 9 will be 3 square. Okay, now we have got the denominator which can give you the numerator. So integration will be something like this. Cos x minus sin x. Denominator will be 8 will be of course 3 square we got. Sin x plus cos. This sin x plus cos x will give you directly cos x minus sin x because I'm taking t as sin x plus cos x. So dt by dx will be equal to sin x will be cos x will be minus sin x. So cos x minus sin x you can write. So there is no problem here. In the previous question we had a negative, so we have to take the negative on the other side. But here it's directly you can do it. Cos x minus sin x we have. Dx can be taken on the right. So this cos x minus sin x into dx is dt. So this will become dt integration of dt divided by 3 square minus, I took t as sin x plus cos x. So 3 square minus t square. A square minus x square it is. This will be sin inverse t by 3. Sin inverse x by sin inverse t by 3. So sin inverse what was t? It was sin x plus cos x. So sin inverse sin x plus cos x and divided by 3 plus constant of integration. That's your final result. The only effort is that previous question was under root sin 2x. This is 8 minus sin 2x. So how to make it as, how we can get a 9 so that we get 3 square minus something. So this is your final result. I hope you'll be able to do this in examination in a proper way. So this is all about this exercise. Thank you so much. Have a good one.